All right, y'all, we're on the home stretch. Okay, so these are things that we kind of have already done, but I did it at the end just because I felt like we needed to have kind of a wrap up of all this. So example 30 says, find f of x when f prime of x is 3x squared and f of 0 equals 5. So if I'm going to find f of x, I just need to find the antiderivative, or the integral, of 3x squared dx. Once I find the antiderivative, I know that on my function f of x, there's an ordered pair when x is 0, y, the output, is 5. I'm going to use that to figure out what c is. All right, so I'm going to do a equals 3, n equals 2. I'm going to take the integration here. So that's going to be 3 over 2 plus 1. And again, if you need it, I'm using this rule right here. Times x squared plus 1, because you have to add that 1 on there. So this is 3 over 3, which is really just 1, x to the third power, plus c. So this is my f of x. Now, in order to figure out what c is, I know that this ordered pair is on f of x, because f of 0 is 5. This is my x. This is my y. So I'm going to say, instead of f of x, I remember that's y, so 5 equals x to the third. I know x is 0 plus c. Solve that and you get 5 equals c. So now you know the rule. F of x equals x to the third plus 5. Okay. The next one, example 31. F of x equals, or find f of x when f prime equals all this, and f of 1 equals 0. Well, that means I'm going to need to integrate. Now, as I write this, I'm going to break it apart into fractions. 3 over 3x squared dx plus 2, the integral, 2x cubed over 3x squared dx. I need to find that. When I do, I know that this ordered pair, when x is 1, y is 0. All right, so 3 over 3. Well, I'm going to simplify that. That's like 1 over 1, or that becomes 1. So I'm going to move this up and say x to the negative 2 dx plus, this one right here is still going to be 2, but the x is going to be on top, and I'm just going to have a 3 on bottom, dx. Again, that's just basic algebra. When I integrate, I'm going to end up with a is 1, n is negative 2 on this first one. So 1 over negative 2 plus 1 times x to the negative 2 plus 1. Plus, this one, my a is 2/3, and my n is 1. So I'm going to have 2/3 over 1 plus 1 times x to the 1 plus 1. I know I'm going to have to put plus c, but I'm going to go ahead and say equals 1 over negative 1, that's going to be negative 1 x to the negative 1. This right here, 2/3 over 2, so that's going to be 2 over 6 x squared plus c, some constant c. I could simplify that one more time, and I'm going to go ahead and call it f of x, because now I've integrated it. I'm going to say negative 1 x to the negative 1 plus 1/3 x squared plus c. I'm going to use this ordered pair. X is 1, y is 0 equals negative 1, and my x value is 1, plus 1/3, my x value is 1 again, plus c. 0 equals negative 1. 1 to the negative 1, that's just like 1, so this ends up being negative 1. Plus 1/3 times 1 plus c. Okay, so 1 and 1/3, if I'm subtracting that, that's going to give me 0 equals negative 2/3 plus c. I'm going to move 2/3 to the other side and get positive 2/3 equals c. Now I know what c is, so I'm going to put my final f of x equals negative 1 over x to the negative 1. That's a whole lot like negative 1 over x. I'm going to move that negative 1 down. Plus x squared over 3 plus 2/3. Lots of different ways I could write that. I'm just writing it without negative exponents. I get the impression from IB they don't really care about the negative exponents. I haven't seen much about that. All right, 32. Now I'm going pretty fast on this, so if you need to go back and rewatch those videos, feel free. Okay, that looks a little bit blurry, but I think I don't know if that's my camera or not, or my contacts. I can never tell. I'm just going to go with it. Okay, so find f of x when f prime of x is this. The point 31 is on the graph, and we're going to use y equals f of x. First off on this one, because I can't use the product rule on integration, I'm going to have to say that f prime of x equals, I'm going to have to do some hippity-hoppity here. X squared times 1 would be x squared. X squared times negative 1x is going to be negative x. Negative 1 times x is going to be negative x. And negative 1 times negative 1 over x is going to be a positive 1. Now that is just algebra. If I lost you on that, go back and write it out. Use your box, whatever you want to do. I'm not going to spend a lot of time on that. That's just basic algebra. X squared minus 2x plus 1. Okay, so I've simplified the derivative. Now let's do our integral. So we're going to integrate x squared minus 2x plus 1 with respect to x. All right, so this is going to give me f of x. Okay, so I'm going to integrate term by term. So this is going to be 1 over 2 plus 1, x to the 2 plus 1. I'm going to go ahead and say plus negative 2 over 1 plus 1 times x to the 1 plus 1. Plus, let's see, 1 over 0 plus 1 times x to the 0 plus 1 plus c. Again, go back and look at your derivative rules if you need to. So let's see, that's 1/3 x to the 3rd minus, that's going to be 2 over 2, so that's going to be 1x squared plus 1 over 1 x to the 1, so that'll just be x plus c. I'm going to double check my answers, make sure I got that. 1/3 x to the 3rd minus 1x squared plus x. Okay, so this is f of x. Now, I know that the ordered pair, it told me that 3, 1 is part of this function. This is x, this is y. I'm going to plug in the y, which is 1, equals 1/3, x is 3. 3 cubed minus 1 times 3 squared plus 3 plus c. Simplify all that. I ended up getting c equals negative 2. 1 equals, this right here is going to become 9 minus 9 plus 3 plus c. And this is going to give me c equals negative 2. So my function, I'm going to go back up here, is f of x equals 1/3 x to the 3rd minus x squared plus x minus 2. There's my final function. All right, so that's those. Now I'm going to go over to some kind of just really some physics problems. I feel like most of these you're going to already know. All right. So a car is traveling in a town with a speed of 13.5 meters per second. So this car hits this town and it's already going a whopping 13.5 meters per second. When the car leaves the town, the driver starts accelerating. So as he leaves town, maybe there was a speed zone or something. He starts accelerating at a constant acceleration of a equals 4 meters per second. Find the speed of the car 3 seconds after it starts accelerating. Okay. So let's go back to physics, and let's remember what we know. So we know that acceleration, maybe we should put it this way. Acceleration is the derivative of velocity. That's something that we already know. The velocity is, to get the velocity, how would I get the velocity? Well, how would I get that? How would I get just the velocity? Well, if the velocity derivative is the acceleration, could I do the antiderivative of, let me write it this way, of the acceleration with respect to t? If this is the derivative, could I say that v of t equals the antiderivative? Yeah. So if I just integrate the acceleration, I can get the velocity. One of the things it does tell me in this problem is that the driver starts to accelerate with a constant acceleration of 4 meters per second. So I know the acceleration. If I know the acceleration, I can figure out the velocity. So here we go. We're going to take the integral of 4, because that's the acceleration. Well, if we integrate that, we're going to get the velocity. So that's going to be, I'm going to give you a second to think about it. It would be 4 over 0 plus 1, and then we'll use t to the 0, because it's not there, plus 1. So that means it would be 4 over 1, so it would be 4t to the 0 plus 1 is 1, plus some constant c that I don't know. Now remember, when you integrate, if I were to take the derivative of 4t, 1 times 4 is 4, and this would become 0, and it would go away. So really, when you just integrate a number, you just throw the variable up there. That's all you got to do. Okay, so what do we know? So we know that when we start on this city, when we hit this city, we're already going 13.5 meters per second, right? Think of it like this. I want to say that, so the speed, I'm just going to write this in words for you. The speed is 13.5 meters per second. So our starting time, like when x is 0, or when t is 0, at that moment when we hit that city, we're already traveling at a velocity of 13.5 meters per second. It tells us the car is traveling in a town with a speed of 13.5 meters per second. If I were to write this, that would mean at time 0, when I hit the city, I'm already traveling 13.5 meters per second. I can use that information because right now I know that the velocity function is 4t plus c. I can use this information. I still haven't gotten what I need. I need to find the speed of the car at 3 seconds. So when the time is 3, I need to figure out what it is. But I don't have enough information yet. So what I'm going to do is plug this into here. Once I know c, I can solve this. So v of t, so that's 13.5 equals 4 at the time of 0 plus c. So that means, which if you think about this, y'all, this makes sense. The constant is 13.5 meters per second because that's my constant speed that I was going at the beginning. So v of t actually equals 4t plus 13.5 meters per second. I want to know, how fast am I going at 3 seconds? Can you figure that out? Yeah, after 3 seconds, I would do v of 3 equals 4 times 3 plus 13.5. So velocity at 3 seconds, 12 plus 13.5, isn't that 25.5 meters per second? Again, a lot of physics there. And if you know another way to solve that using your physics, go for it. They won't care. All right, the last one. I think this is the last one. Yeah. Okay, so this one has, y'all, this one has like some serious algebra in it. If you're an algebra geek like I am, you will love this one. Find the line, or the line y equals 4x plus 9.875 is normal. Oh, look at that vocabulary. Normal. to the graph of y equals f of x. It is also given that f prime of x is 2x to the third. Find f of x. Okay, couple of things. And right off the bat, you may be thinking, well, if I'm going to find f of x, I already know I'm going to have to integrate 2 over x to the third dx. Okay, well, let me just integrate that because I know how to do that. So a is 2, so it would be a over, and we're going to remember we have to make this be x to the negative 3. You know what? I wonder if I should go ahead and write that for you. Let me just write it because sometimes I skip too many steps and I lose people. So let's do 2x to the negative 3 dx. Okay, so let's integrate that. A is 2, n is negative 3 plus 1, x to the negative 3 plus 1. So that is 2 over negative 2. So that's like negative 1. X to the negative 2 plus c. Ooh. Okay, so that's good. I know the function. But usually if I'm going to find f of x, I have to know some ordered pair x comma y that's on that graph. I don't know it. I don't know x comma y. I do know that it has a line y equals 4x plus 9.875. That's normal. Do you remember what normal means? If I have the line, I'm going to do this in red, y equals 4x plus 9.875. If it's normal to the graph, ooh, do you remember that means it's perpendicular? So the slope of this line right here is 4. That would mean that's the normal. So I need to take the perpendicular of that slope, which would be negative 1 over 4. So that means the slope of the tangent line, not the normal, but this would be the normal, this would be the tangent line is negative 1 over 4. Oh my goodness. Okay, you got to really think about this. The tangent line is the slope. What gives me the slope? The derivative. The derivative gives me the slope. So if I can take the slope, which is the derivative, and say negative 1 over 4 equals 2 over x to the third. Solve that for x. That'll be my x. Then I have to figure out the y. Okay, so let's find x right here. So I'm going to cross multiply. So that's negative x cubed equals 8. I'm going to throw that negative to the other side. So x cubed equals negative 8. The cube root of both sides, I'm going to move this up just a little bit, would mean that x equals, hopefully you're thinking it, negative 2. So that means this ordered pair has an x value of negative 2. Okay. Now I know that there's some ordered pair out there, and on my graph of this, it goes through negative 2, but how do I find that point right there? Hopefully you're thinking, well, I know this line right here, and on this line, the slope of it's 4, it goes through negative 2. Could I take negative 2 and plug it in? And that would give me the y value that's on that line, and that would be on the curve too. Yes. So we're going to take negative 2, plug it back in. Y equals 4 times negative 2 plus 9.875. So y equals negative 8 plus, so that's going to be 1.875. Okay, so that means, I'm going to move this over a little bit. That means on this line, I needed a point on this line that was also on my curve. Well, the derivative, remember the derivative is the slope of the tangent. They didn't give me the tangent, they gave me the normal. So I had to flip the normal to get the slope of the tangent, plug it in, solve for x. Now I know the y is 1.875. Now I know on this curve, there's a tangent line or a normal line that goes through this point. So now I can figure out C. So f of x equals -1 x to the -2 plus c. I know the y value is 1.875 equals -1. I know that the x value is -2 plus c. Solve that for c. Okay, guys, when I solved that for c, I got c equals, that's just algebra, hopefully you can do that, 2.125. Just a reminder, -2 to the -2 power, that's 1 over 2 squared, which is 1/4. You still have a -1 on top, so it's like -1/4. You're going to add that to both sides, and that'll give you that. So, the final answer, what is f of x? Well, let's see. It's -1 x to the -2 plus c, which is 2.125. I would probably clean that up a little bit and say -1 over x squared plus 2.125. Bam! And that concludes our calculus unit. Hopefully you did some of the cognitive to help you out. Watch for another check for understanding over boundaries.